So it says use the substitution x is equal to 2 sine theta to find the exact value of the integral between 0 and root 3 of 1 over 4 minus x squared to the power 3 over 2 dx. Now, remember, you're dealing with an integral in terms of x, right? You want to get this integral in terms of theta, yeah? Because the integral as it is not a nice one. We don't know how to integrate that. So we need to use a change of variable, in this case theta, to integrate it. So firstly, if I look at my expression, I've got x. Hold on, let me make this a bit bigger. I've got x is equal to 2 sine theta. Now, in my expression, I've got 4 minus x squared. So I'm going to work out what that is. Yeah? Right. So, firstly, x squared, do we agree is going to be 4 sine squared theta? Yeah? So, if I want 4 minus x squared, then that's just going to be 4 minus 4 sine squared theta. Do you agree, guys? Does that make sense? Good stuff. So I'm going to put that in. So it's going to be the integral between 0 and root 3 of 1 over, and then I've got 4 minus 4 sine squared theta, like that. And this is all to the power of 3 over 2, isn't it? And then dx. Okay. Now, as well as that, that dx needs to go. So I know that x is equal to 2 sine theta. To get the dx, we always differentiate. Could somebody remind me what is dx d theta? Exactly. Well done, Keishan. 2 cos theta. Brilliant. Well done, Alfie Suramori. Good stuff. So now that means the x then is going to be times up to d theta, 2 cos theta d theta. Yeah? So I'm going to put this on top here. So it's going to be integral of 0 of root 3 of 1 over 4 minus 4 sine squared theta to the power of 3 over 2. And we now know that dx is 2 cos theta d theta. Anybody get here? Good stuff, right? So let me just make this a bit neater. 0 and root 3 is there. I'm going to put that 2 cos theta on the top. Like that there. You just make this a bit better. On the top. And then that's going to be 4 minus 4 sine squared theta to the power of 3 over 2. And then d theta. Right? Ah, fair enough. Fair enough. So you'd get a different answer then. Now, remember, this is a definite integral. What do I need to do that I haven't done yet, guys? Fantastic, Alfie and Kayshawn. We need to change the limits, right? Super, super important. So remember, it was an integral in with respect to x. So this means that x is equal to root 3 and x is equal to 0. So if x is equal to, what was it? 2 sine theta, right? X is equal to 2 sine theta. Then we need to change these limits, don't we? So that would mean that I'd have root 3. Let me just write x is root 3 here. Like that. That would mean I'd have root 3 is equal to 2 sine theta. So I'm going to say that root 3 over 2 is equal to sine theta. And I'm going to find out what theta would be in that case. So let me put this here. And then I'm going to do the sine inverse. So I'll calculate the radius, sine inverse of root 3 over 2. Like that. That's going to be pi over 3. So theta is going to be pi over 3. And then for the next one, x is equal to 0. That's going to be 0 is equal to 2 sine theta. I know that theta is 0 anyway, but it's always good to do it. Divide by 2, 0 is equal to sine theta. Take the sine inverse of 0. I'll just do it here. Sine inverse of 0. Oops, sine inverse of 0 is just 0. So therefore, these are our new limits of integration. Pi over 3 and 0. So that means that this question becomes 0 pi over 3 2 cos theta over 4 minus 4 sine squared theta to the power of 3 over 2 d theta. Anybody get her? Okay. What did we do from here? How do I go about this? Remember, it's trigonometry. I was going to say trigonometry. It's trigonometry, right? Whenever you're dealing with trigonometry, no matter where, well done, Alfie, no matter what you're dealing with, right? No matter if it's just trigonometric identities, if it's in mechanics, projectiles, anything, your identities. Always think about your identities. Yeah. Now, when I look at this here, for me, I can say, okay, well, fine. I've got 4 minus 4 sine squared theta. What I notice is that, well, 4 minus 4 sine squared theta is the same as I can take out a 4 and then I get 1 minus sine squared theta. Because somebody remind me, what is 1 minus sine squared? It's cos squared, isn't it? Right? So this is just 4 and then cos squared theta. So I can actually rewrite this here. So I'll just work with the numerator for now just to save time. So it's gonna be 4 and then cos squared theta, right? To the power of 3 over 2, isn't it? Let me just put this in yellow so they know, so we know what I'm working with. That right there, this right there is the same as this right here. Now, can this be simplified, guys? Okay. The question was to the power of 3 over 2. So that's why I've got 3 over 2 there. But now, what do I do from here? Well, if you think about that, 3 over 2, doesn't that mean I'm going to have a 4 cos squared theta, like that, then square rooted all to the power of 3. Do we agree that's the same thing? Yeah. Are we happy with that so far? Yeah. Good stuff. What is the square root of 4 cos squared theta, guys? Exactly. It's just 2 cos. So it's just 2 cos theta all cubed, which is equal to exactly. It's 8 cos cubed theta. So the actual integral becomes, I've got the integral between 0 and pi over 3. It's 2 cos theta on the numerator. It's over 8 cos cubed theta on the denominator, d theta. Now what happens here is, okay, well, fine. That 2 and that 8, that will cancel to be a quarter, right? Pi over 3. And then I've got cos theta over cos cubed theta. That is going to be 1 over cos squared theta. So it's going to become 1 over 4 cos squared theta d theta. Did anybody get here? Okay, if you didn't get here, does it make sense now? For anyone that didn't get here? Yeah, good stuff. Surumuri makes sense? Good stuff. All right. How do I integrate that? How do I integrate that? Anyone have any ideas? Well, remember, again, you're dealing with trig, identities. That's why it's so important to know your identities off by heart. So whenever you're faced with anything, you know what they are also equal to. Now, remember, that 1 over 4 cos squared theta, right? I can write this close, not 4. It's going to be a quarter, isn't it? Because it's going to be 1 over 4 times by 1 over cos squared. Do we agree, guys? That can we write it like that? Yeah. What's 1 over cos squared, guys? Not cosec, sec squared. That's 1 over sine squared. Yeah, well done, guys. So it's actually a quarter sec squared theta. So all of that has just simplified to become a quarter sec squared theta. Now, do we know what the integral of sec squared is? We should do. It's a standard integral. Anyone know? No, that's when you differentiate sec. If you differentiate sec x, that's sec x tan x. Fantastic, Alfie. The integral of sec squared is tan. When you differentiate tan, it's sec squared. Remember, you use the quotient rule. We write tan the sine of a cos, use the quotient rule, you get sec squared. So this here is just going to be a quarter tan theta between 0 and pi over 3. Does that make sense, guys? We already said the integral of sec squared, the theta, is just tan theta plus c. Yeah, we happy with that, guys? Yeah. So now what we're gonna do here is second find polygon limits a quarter tan pi over 3. Take away a quarter tan of 0, like that there. Now I know that's 0. I don't need a calculator for that. I need a calculator for the other one though. I don't know what that is. Where's my calculator? It's over there. A quarter tan pi over 3, a quarter tan pi over 3, tan pi over 3 is root 3 over 4. So therefore the final answer is root 3 over 4. And what is that? That's the Alpha, you got that correct. You put 0.43 in the chat. So well done. Yeah, but it did say exact value though, so you drop a mark. Yeah, they want it in terms of a third. If they say exact value, they want it in terms of a third, a pi, and stuff like that. Does that make sense, guys? Let me just zoom out so you can see all the working. How did we find this question? Put a 0 if it was very difficult, very challenging, or put a 10 if it's easy, you get it, and you could definitely do another question like that again. 2, 5, 7, 7. Okay, how do we find integration of substitution overall as a topic, especially for those of us that are doing it for the first time?